Hello everybody, welcome back to the channel. This is a brand new video, and I'm Aster. And today is the first episode of Terrific Trigonometry, where we solve a couple of trigonometry problems. Um, and today we'd be doing the ones I've shown you right over here. And I suggest you grab a pen, a piece of paper, and some water before you start, so you can try the problem for yourself, but I'll be solving the problem here regardless. So without any further ado, let's begin with this one over here, the first one. So as we see, it's secant x to the power of 4 times 1 minus sine to the power of 4x minus 2 times tan square x equals 1. So we could transpose the minus 2 tan square x equals 1 to the RHS. So this would become to the power of 4x times this 4 times 1 minus sine to the power of 4x, right, equals 1 plus 2 tan square of x, right? So what I'd suggest over here to do is to split this up into 1 plus tan square x plus tan square x, because then we can use the formula, because then we can use the identity 1 plus tan square x equals the quotient square x, right? So we can use this identity and rewrite this as say quotient square x. Oh yeah. I'm just new to the software, so I don't know much. So yeah, we can simplify it down to just this much, right? Let's just keep this over here. It'll come handy later on. Now that we have this, we can write say quotient to the power of 4x. We can write say quotient to the power of 4x over here as 1 by cos to the power of 4x, right? So we can rewrite this as cos to the power of 4x. Simple as that. Now what we do over here is, we can write 1 as 1 to the power of 4 too, right? That works, exactly, right? Yeah. So we can use the identity a square minus b square equals a plus b times a minus b. Yep. So we can use this formula, and we can rewrite this now as just a minute, as 1 square minus sine square x times 1 square plus sine square of x, right? So we can do that, absolutely. Yeah, and this again we can use the identity. We can use the identity over here. We can use the identity. Yeah, I remember. Sine square x plus cos square x equals 1. So we have this identity over here, and if you transpose a bit, so if you transpose this a bit, you can write this as cos square x equals 1 minus sine square x, right? Works out. So we have this over here, and 1 square, and 1 square is just 1. That's common knowledge. So we can rewrite this now as simply cos square x. right? So we can write this over here. So now we have another factor, right? So over here, so we can cancel the 2's out over here, the 2 over here, right? The 2 over here, and the 4 over here, right? So we can cancel that out. This becomes 2 because of division, and this cancels out completely. This becomes cos to the power of 0. When anything to the power of 0 is simply 1. So this is what we're left with right now. Okay. Next, what we can do is transpose the secosine square x to the LHS side. So this will become minus secosine square x and remove this, right? And we can write 1 minus secosine square x as just minus of 1 by cos square x, correct? We can write this as that. So let's just remove the brackets for either calculations. So we have this. So because they both have the same denominator, we can directly subtract. So 1 and minus 1 cancel each other out. Yep, they cancel out, and they cancel out, and what we're left with over here is sine square x by cos square x equals tan square x. So now we can further simplify this to x sin of x, and we can further simplify this to sine of x by cos of x whole square, which, as we know, sine of x by cos of x is simply tan of x squared, which we can again write this as tan square x. So LHS equals RHS. So we have proven this statement, right? Now we have these as the identities. Let's just mark these as I1. Okay, this is a lot easier then. Let's just mark this as I1 for identity 1. We can mark this as I2 for identity 2. Let's just put this one over here to avoid confusion. Okay, so we have our identities over here, and then we can have I3 over here as this identity. Okay, so we have this, and now let's head on to the other problem. Tan of x by secosine square x plus cotan of x by cosecant square x equals sin of x times cos of x. So let's start. So we can write tan of x by secosine square x simply as tan of x. So this can be this is the same as tan of x times 1 by secosine square x, which the reciprocal of a reciprocal is just the original number, right? So 1 by x to the power minus 1 is just x. So it will become tan of x times cos of x, and plus this will become cotan of x by this is sine square x. So wait a minute. Yep, this is cos square x. Then we have over here cotangent of x times sine square x. Now we know that tan of x is simply sin of x by cos of x. So the cos over here, cos square cancels out, and this simply becomes sin of x. Oh no. Sin of x times cos of x plus, again, I believe it's the same thing. And this becomes cos of x by sin of x times sin square x. So this becomes again cos of x times sin of x. Um, so this being sin of x times cos of x, this won't be true, as you can easily see that this would become 2 sin of x times cos of x equals sin of x by cos of x. So this, if you cancel them out, this just becomes 2 equals 1, which I believe is very obviously not true. So this is proven as false and this is true. Let's just write this over here. True and false. So we did two problems here, two trigonometry problems here for this episode of Terrific Trigonometry, and I'll be doing more problems in other future episodes. And if you have any recommendations for other problems or ideas, please do put them in the comments. And thanks for watching. So bye and have a good day.